We're going to go over lesson 3.2, Trig identities and equations. We're going to use the formula for the cosine of the difference of two angles, use the sum and difference formula for cosine and sine, and use the sum formula for tangents. So we're going to start here with our formula, the cosine of the difference of two angles. The cosine of alpha minus beta is given here by cosine beta plus sine alpha sine beta. The cosine of the difference of two angles equals the cosine of the first times the cosine of the second plus the sine of the first times the sine of the second. So our first example is, we know that the cosine of 30 degrees is the square root of 3 over 2. Obtain this exact value using this formula, and the difference formula. So we know, if we're using the cosine difference formula, that the cosine of 30 degrees is equal to cosine 90 minus cosine 60. Well, going from our formula, well, this will translate into cosine of 90 times the cosine of 60 plus the sine of 90 times the sine of 60. Well, the cosine of 90 is 0, the cosine of 60 is 1/2, the sine of 90 is 1, and the sine of 60 is the square root of 3 over 2. So 0 plus the square root of 3 over 2 is the square root of 3 over 2. So we have verified our first problem there. The next one asks us to find the exact value of cosine 70 times the cosine of 40 plus the sine of 70 times the sine of 40. We recognize that as the difference formula for the cosine, and we know that that is equal to the cosine of 70 minus 40. So it's equal to the cosine of 30 degrees, which is the square root of 3 over 2. So there are two examples of how to use the cosine formula for differences. We are also asked to verify an identity. Cosine of alpha minus beta over cosine alpha cosine beta equals 1 plus tangent of alpha tangent of beta. And what we'll do is we will start on the left hand side, and we know that this is the same as cosine alpha cosine beta plus sine alpha sine beta over cosine alpha times cosine beta. We will break this into two fractions. This is cosine alpha cosine beta over cosine alpha cosine beta plus sine alpha sine beta over cosine alpha cosine beta. The first fraction simplifies to 1. The second is sine alpha sine beta over cosine alpha cosine beta. Here we see that what we actually have, if we split this according to its angles, is 1 plus the tangent of alpha times the tangent of beta, which is exactly what we were supposed to get. We have some more sum and difference formulas that I want you to be aware of. You may want to stop the video and take a picture. You may want to write these down, but you'll need to reference these to finish this lesson. It asks us to find the exact value of the sine of 5 pi over 12 using the fact that 5 pi over 12 is equal to pi over 6 plus pi over 4. So we'll start here with the sine of alpha plus beta equals the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. That's our formula. 5 pi over 12 is what I'm finding the sine of. So what I'm going to need to do is break that apart, and that's going to equal the sine of pi over 6 plus pi over 4. I'll use this in place of alpha and this in place of beta. So I have the sine of pi over 6 times the cosine of pi over 4 plus the cosine of pi over 6 times the sine of pi over 4. Now, using your unit circle, your reference sheet, you know that this is a value of 1/2. This has a value of the square root of 2 over 2. This has a value of the square root of 3 over 2. And this has a value of the square root of 2 over 2. We'll simplify our arithmetic. We're going to get the square root of 2 over 4 plus the square root of 6 over 4, which is the square root of 2 plus the square root of 6 over 4. And that will be my final answer for that problem. Next problem says, suppose that the sine of alpha is 4/5, and this is in quadrant 2. If it is in quadrant 2, x is negative and y is positive. That's what they're telling you that for. And suppose that the sine of beta is 1/2, and it is in quadrant 1, where x is positive and y is positive. Find the exact value of cosine alpha. Well, if you know that the sine is 4 over 5, you know that that is y and that is r. So we're going to use Pythagorean theorem. So y squared, pardon me, plus x squared. So we have x squared plus y squared equals r squared. So x is what I'm looking for. Y is 4. R is 5. So I have x squared plus 16 is 25, which gives me x squared is 9. So x is positive or negative 3. But because I am in quadrant 2, x has a value of negative 3. So to find the cosine, I'm going to need x over r. The x value is negative 3. The r value is 5. So there's my first answer, negative 3 over 5. They also want me to find the cosine for angle B. Find cosine for angle beta. Same process here. This is y and this is r. So x squared plus 1 squared equals 2 squared. X squared plus 1 is 4. X squared is 3. So x is either positive or negative square root of 3. Well, I'm in quadrant 1, so it's positive square root of 3. The cosine is equal to x over r, so it is the square root of 3 over 2. That is my second answer for that problem. Now they want me to find cosine of alpha plus beta. Now remember, cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So I've got all my values here. I'm going to plug them in. Cosine of alpha is negative 3 over 5. Cosine of beta is square root of 3 over 2. Sine of alpha is 4/5. Sine of beta is 1/2. Simplify. Negative 3 square roots of 3 over 10 minus 4 over 10. Combine into one fraction. This is negative 3 square roots of 3 minus 4 over 10. They also want you to find the sine of alpha plus beta. That formula is sine alpha cosine beta plus cosine alpha sine beta. So I'll plug in. I've got all my values here. Sine of alpha is 4/5. Cosine of beta is square root of 3 over 2 plus cosine of alpha is negative 3/5. Sine of beta is 1/2. So this is 4 square roots of 3 over 10 plus negative 3 over 10. So this is 4 square roots of 3 minus 3 over 10. I'm going to show you the tangent formulas here. Here's the formula for the tangent of alpha plus beta and for the tangent of alpha minus beta. You will use those similarly. Here they're going to verify the identity. Tangent of x plus pi equals tan x. What they do is they use this in the formula, and we know that the tangent of pi is 0. When they plug that in, we get the tangent of x over 1. I hope you do well on lesson 3.2.